Good morning. Welcome to first lecture of antennas and wave propagation. In this lecture, I am going to give brief introduction of antennas and radiation mechanism of single wire antenna, how the radiation will take place. Going to the definition of antennas, what is the main purpose of the antenna? Why should you use an antenna? If you want to send any data in free space, if you want to send any data in free space, the only source is you can transmit or receive any data in the free space by using an antenna. Antenna is the only means for transferring or receiving the data in free space. So without this, it is not possible. There are so many definitions of antenna. Coming to the definitions of the antenna, so antenna is a metallic device which is used to receive or transmit electromagnetic. That is one definition. And the other definition of an antenna is a transmission structure between free space and guiding device. So the main purpose of an antenna is, for example, if it is a transmitting antenna, whatever the power you are giving to the antenna, it is in terms of electrical. Means you are giving the input as electrical. What does the antenna do? It will convert the electrical to, and it will transmit into free space in the form of electromagnetic waves. Means it is when in the transmitting antenna, it is converting an electrical signal to electromagnetic waves. Now the electromagnetic waves is radiating in free space. Whereas coming to the receiving antenna, what is the main purpose of the receiving antenna? It will receive the electromagnetic waves and you will give the connection to our TV or anything, which is an electrical signal. So at the receiving end, the antenna is converting electromagnetic signal to electrical. So as we know, what is the definition of a transducer, which converts one form of energy to another form of energy is nothing but transducer. So the other definition of the antenna is an antenna can be used as a transducer, which converts electromagnetic wave to electrical and vice versa. So that is the main purpose of an antenna is it can receive or transmit electromagnetic waves. Okay. Now next. So this is the definition of an this is the basic structure of an antenna. So here in this we are having, so this is the antenna part. Okay, this is transmission line part. For example, now we are transmitting a signal here. So this is transmission line and this is antenna and this is the wave get detected from the antenna and radiating into the free space. Where this antenna is there, the antenna is in between transmission line and free space. So another definition of an antenna is, in the previous case where we have seen this, an antenna is a transmission structure between free space and guiding device. This is another definition of an antenna. So here, up to here, this is transmission line. Okay, in the previous semester, we had discussed regarding the transmission line. What is the major difference between a transmission line and an antenna? In a transmission line, all whatever the signal we are transmitting is a guided. No signal will goes out of that structure. But means we call the whatever the transmission we are using for using that is transmitted to transmission line, we call it as guided medium. Whereas, what is the main purpose of an antenna? It should not transmit inside. Whatever the signal that is received by the antenna, that should be radiated into the free space. Okay, that is the main structure. Okay, so this is an antenna. Up to here, the wave is coming inside, means that is guided one. So what is the output of this antenna? It is unguided. Means in transmission line, you use the word transmission, whereas in antenna, we use the word called radiation, means which radiates into free space. Okay, that is the major difference between a transmission line and antenna. Now, let us discuss regarding a single wire antenna. Okay, so let us see here in this video, let us see here how a single wire antenna will radiate into the free space. Okay, let us see here. We will see here how a single wire antenna how, what is the source for an antenna to radiate. In the transmission lines, we will take, for example, transmission line, all the signal will propagate inside it. No signal will go outside, that is nothing but radiate. Let us see what are the different modifications or what are the requirements for a single wire to radiate. Okay, the main purpose of a transmission line is transmission. The main purpose of an antenna is radiation. How radiation is achieved by an antenna in single wire? If you take a single wire, how to convert it to an antenna? We will see here. That is the basic one. Let us consider a conducting wire of material whose prominent characteristics is the motion of electric charges and creation of. Let us assume that this is a single wire. Let us assume this is a single wire. So in the single wire, so it is the total area of cross section is A and the length of the wire is L and it is having the volume of V. Okay. Let us assume the current and the let us assume the electrical volume charge density E. The total current Q within the volume V is moving in the direction with the uniform velocity Vz. Okay, so the velocity with what the charge is moving, it is denoted with Vz. It is moving is denoted with Vz. Okay, that is denoted with Vz. Now the total current density. So what is the definition of the current density? Nothing but current per meter. Because the current density ampere per meter over the cross section of the wire is given as Jz is equal to QV into V. Jz is equal to QV into Vz. So what is this QV charge and what is this Vz velocity at which the charge is moving? So this Vz small Vz indicates the velocity at which the charge is moving. Okay. For example, let us consider here if the wire is made up of wire, what is meant by perfect conductor? In a perfect conductor, where does the current pass? Always in a perfect conductor, the current will pass on the surface, only on the surface. Okay, it doesn't goes inside. Okay. So if you assume that the whatever the wire we have taken up to now, if it is a perfect conductor, all the current will move on the surface. So then the current density, since in this case the current density is equal to Qs into Vz. What is this Qs? Qs is coulombs per meter cube. In the previous case, Q is coulombs per meter cube. Here, the Qs is charge surface. It is coulombs per meter cube. Okay. So this is the expression. For example, let us assume initially we have assumed the volume charge. Later we have assumed that it is a perfect charge. Then it has perfect conductor. Then the equation has came like this. If we assume that the wire is very very thin, okay, the wire is very very thin, let us that the wire is very very thin. Okay, then since current per meter, the wire is since very thin, it will becomes Iz is equal to QL into Vz. What is this? QL coulombs per meter, that is charge per unit length. Okay, so totally we have got three equations. Okay, so first let us assume this equation, this equation is sufficient. Okay, so for example, if we derivate this above equation, this 1.1c with dt. Okay, so I will get a dI over dot is equal to QL into dou Vz by dou t. So Vz, small Vz is velocity. What is the differentiation of velocity? It is nothing but acceleration. Az represents the acceleration. QL is the charge per unit length. So dIz by dt is QL by QZ is equal. This is equation. Means if the wire is of length L, you have assumed that what is the length of the wire? The length of the wire is L. So if you simply multiply this, L into dI by Z is equal to L into. So there are this equation, this dou V Z by dou T can be replaced with acceleration. So this is the fundamental equation. If anything, if any wire or anything you want to radiate, this is the fundamental basic equation which gives the relationship between current and charge, current and charge. Okay, so this is the fundamental relation for electromagnetic radiation. If anything want to radiate, this equation serves as the basic fundamental relation which gives the relationship between current and charge, which gives the relationship between current and charge. From this equation, how the radiation is possible. from this equation how the radiation is possible. Okay, so see here, to create radiation, one thing is there must be a time varying current. So dou I by z by dou z means if a radiation should occur means compulsorily the first component is there should be either time varying current or acceleration or deceleration of charges should be there. So AZ denotes the acceleration. Either means whatever the charges that are moving, they should not move with uniform velocity. They should move with acceleration or either increasing or decreasing, in this fashion. If the charge is moving in this fashion, automatically there is a chance for radiation. Or what is the other chance for radiation? Compulsorily there must be time varying currents. So this is the fundamental equation. If any device want to radiate, how the charges should move, either in the accelerating or deaccelerating mode, or the compulsorily if there is time varying current, compulsorily there will be radiation mechanism. This is the basic fundamental rule for anything to radiate. Okay. So to create radiation there must be time varying current or acceleration or deacceleration of charge carriers must be there. Okay. So see here, let us see here how the radiation is possible. For example, if the wire is straight, there is no chance of radiation, because if the wire is straight, all the charge carriers will move with uniform velocity. So if the charge carriers are moving with uniform velocity, there is no radiation. Why? Because we have already derived in the previous expression that if the charge carriers are moving with accelerating or deaccelerating, then there comes the concept of radiation. Okay, let us take these are the different sources where the radiation takes place. If the wire is curved, since if the wire is curved means, for example, let us see here, up to here, up to here, the waves will come like this with the uniform velocity. Okay, after that, here there is a small bend. Let us consider up to here the waves are coming with the uniform velocity. Since there is bend, there is a change in acceleration of the charge carriers. Means there may be increment in the charge carriers or decrement. But whatever the velocity which the charges are coming up to here is not same as the velocity the charges are moving in this direction. Means there is a change in movement of charge carriers. There is a change in movement of charges. This leads to radiation. Okay, means either if the curve is curve, if the wire is curved, there is a chance of radiation. If the wire is bent, there is a chance of radiation. If the wire is discontinuous, so see here up to here there is this volume is one, up to here the other volume is one, there is a chance of radiation. The last case is if the wire is terminated, then also the wave comes into the radiation comes into picture. Then also the radiation comes into picture. Okay, so these are the different sources where there is a chance of radiation. If the wire is curved or bent or discontinuous or terminated, then there is a chance of radiation. Okay, so from this explanations, we can conclude that even though if the charge is not moving, current is not created and there will be no radiation. This is the first case. No current will be there, no charge will be there, then no radiation will be there. Second case, even though the charge is moving with uniform velocity, if the charge is moving with uniform velocity, what I have told that if the wire is straight, even though if it is moving with uniform velocity, there is no radiation. There is no radiation if the wire is straight. Okay. So there is radiation if the wire is curved, bent, discontinuous, terminated, truncated, as we have shown in the previous diagram. Okay. The third chance is if the charge is oscillating in time motion, it radiates even the wire is straight. So finally, we conclude that what are the sources for an antenna, any wire to radiate? The first one is not to radiate is if there is no current or if there is no accelerating or deaccelerating charge carrier, there is no radiation. When the current comes into picture, if the wire is curved or bent or discontinuous or terminated, there is a chance for this is if the structures are like that, then there is source of radiation. And other one, if the charge is oscillating in time motion, it radiates